Now for another example where we will be using completing the square, we have the equation 5x squared minus x is equal to 8 plus x. Now we first need to get the x squared and the x terms on the same side. So we'll next subtract an x from each side. So we have 5x squared minus 2x is equal to 8. Now, because the coefficient of the x squared term is not 1, we need to next divide every term by 5. So we then have x squared minus 2/5 x is equal to 8/5. Now, if we come up here and decide what we need to add to complete the square, we're going to take 1/2, the coefficient of x, which is negative 2/5. That will simplify to negative 1/5. Then if we square that, negative 1/5 squared will then become 1 over 25. So that's what we need to add to complete the square. So we have the x squared minus 2/5 x plus 1 over 25. And of course we need to add that to the right hand side to keep the equation balanced. Now factoring the left hand side, we have x minus 1/5 then, quantity squared. And we will need to get a common denominator on the right hand side. So the 8/5 will turn into 40 over 25. Then plus the 1/25. So we then have x minus 1/5. Quantity squared is equal to 41 all over 25. So now we're at the point where we can take the square root of each side of the equation. And so if we take the square root of each side, we're going to have then x minus 1/5 is equal to plus or minus the square root of 41 all over 25. And then we have x minus 1/5 is equal to plus or minus the square root of 41 all over 5. And then isolating the x, we'll add 1/5 to each side, so we have 1/5 plus or minus the square root of 41 divided by 5, and writing as a single fraction, we have 1 plus or minus the square root of 41 all over 5. Now that form is fine, and if you should want to get a decimal approximation to the solutions, you would need to write the values of x separately. So that would then produce 1 plus the square root of 41 divided by 5. And the other x value then would be 1 minus the square root of 41 divided by 5.